In this video, we'll be talking about the definition of the derivative. Now, the derivative is nothing more than the limit as h approaches 0 of the difference quotient. So we've worked with the difference quotient before such that f of x plus h minus f of x all divided by h. That right there behaves as though it's a slope. So the derivative behaves as though it's the limit of that slope value as we get closer and closer to those two x numbers being the same. This is one way that you may see that definition of the derivative. This is a second way. Notice the only difference between these two is that h is replaced with delta x. Now this form right here is a little bit better to work with, but sometimes it's more complicated to understand. The reason why this one's better to work with is because delta x is generally referred to as a change in x. And if this is a change in x, the change in x is getting infinitesimally small, closer and closer to 0, causing this function minus this function to be getting closer and closer to each other, and the value in the denominator getting closer and closer to 0, such that the two x values that we pick are getting closer and closer together. The second definition only refers to working the derivative at a point. So if I'm trying to find the derivative at a very specific point, I can simply use this derivative rule such that my x value that I'm approaching is the a value that they've given me. So when we're looking at the first example, this one right here, if I'm determining f prime of a, there's actually two ways I could work through this problem. Number one, I could use this case right here, where my a value is 3, and my x value will remain as x. And when I solve this equation, my x will eventually approach the value of 3, allowing me to plug that number in. My second way I could do this is do this generically based on this limit definition up here, where I find it as f of x plus h, I find f prime of x. Once I find the equation after evaluating the limit, then I can simply plug in the value of 3 to that derivative function. These are two different things that you could use. It would be best for you to be able to comfortably and every time be able to do this one. This one, however, might be a little bit more efficient depending on the problem you're given.